What Chapter 6 looks at is how the trigonometry that we've learned in the past, SOHCAHTOA, can start to relate to all four quadrants, and we talked about reference angles and cast rules, and how trig ratios actually relate to the equation of a circle. Now, at the bottom of this page, they have an equation of a circle. And the equation of a circle is really related to a squared plus b squared equals c squared. Because if you take any point on the edge of the circle, which they have right here, some random point, you can always draw a line straight down to your x-axis and a line back to the origin and draw your radius. And that makes a right-angled triangle. Pythagorean theorem works with a right-angled triangle. It's a squared plus b squared equals c squared. What is the equation of a circle? The equation of the circle is just a squared plus b squared equals c squared. But they say, what's this length? X. So x squared plus y squared equals your radius squared. X squared plus y squared equals 1 is the equation of a circle. Because you could pick any x anywhere, any y anywhere on this point, on this circle, and then the value with the triangle that you make, well, this is my x coordinate, this is my y coordinate, this is going to be 1, no matter where I choose a point. So this is something new. You haven't seen an equation of a circle before, but when you realize it's just a squared plus b squared equals c squared, it's not really that crazy. But there are some crazy things that happen as a result of this, which sort of sets the stage for this unit. It's making the connection between trigonometry and points on a circle. First of all, if we took a random point, x and y, we could call this angle theta. And if I call that angle theta, I could say, I know that sine of theta is equal to opposite over hypotenuse. Sine of theta is equal to y over 1. Or I could write that as sine of theta is just equal to y. And cos of theta, adjacent over hypotenuse, would be x over 1, which is just equal to x. Which means that any point that's on the circle, we could write as x comma y, but we can also write, if x is the same as cos and y is the same as sine, any point on the unit circle can be written as cos theta comma sine theta. I'm just going to highlight the definition of the unit circle here. And if you turn your page, at the bottom of your next page, there is some space. I will just open up a new page. At the bottom of your next page, there's some space. At the bottom of that page, in that space, I want you to label 3 big ideas, because these 3 big ideas sort of push us through this whole unit. And big idea number 1 we just figured out. Big idea number 1, wow, got to spell any with an N. Any point instead of writing as x comma y, we can now write it with trig, cos theta comma sine theta. This is our first big idea for this unit. And if any point on the unit circle can be written as x comma y, and the equation of the unit circle is x squared plus y squared equals 1, and the x is the same as cos, and the y is the same as sine, I can write, instead of x squared plus y squared equals 1, I can write cos instead of x squared plus sine instead of y squared is equal to 1. And this is one of the first formulas on your formula sheet, except they write the sine first and not the cos first. And mathematicians don't like writing brackets. So they had to come up with a way to not write the brackets here. And there's a problem with just not writing the brackets. If I just don't write the brackets, can you tell if the whole thing is supposed to be squared or just the angle is supposed to be squared? It actually looks like just the angle is squared. So there's a problem with just taking away the brackets, because the brackets are there to say the whole thing is squared. So mathematicians came up with this idea. They said, okay, I'm going to write sine first. I want the whole thing squared, so I'm going to put the squared there. And then I don't have to write brackets, and that will save me about 13 milliseconds every time I write. You know how we're talking about not wanting to write a lot of stuff? So this is like, oh, perfect. And so everybody agreed that we'll write the squared here when the whole thing is squared. And this is big idea number 2. Go back to our big ideas. Big idea number 2 is sine squared of an angle plus cos squared of the same angle is equal to 1. Now this is pretty cool in that pick your favorite angle. Ilya, what's your favorite angle? 22 degrees, 15 degrees, like 44 degrees, right? So if Ilya was going to write a Valentine to his favorite angle, he'd choose 44 degrees, okay? And so if you took sine of 44 degrees, okay? Mental math, I like to calculate that to 18 decimal places and hold that number in your head, right? Sine of 44 degrees, you've got 18 decimal places of that in your head. Now, you've got that number. I want you to square it and get a result. Keep that number to 18 decimal places in your head. Next, do the same thing with 44 degrees in cos. Cos of 44 degrees, square it, keep that number. So we got two numbers, 18 decimal places. Add them together, and you get 1. See? Great mental math. All right? You never told me any of the answers in between because you didn't know them, but that's okay. It's true as long as this angle is the same, and it works for any angle. If you think it, not just Ilya's favorite angle, 44 degrees, if you're like, oh, my favorite angle is 37 degrees or 73 degrees, or you're really right now feeling like you want to go home and cry because Mom, Dad, everybody else had a favorite angle and I don't have one yet. You know, you can work on that tonight, figure out what your favorite angle is. But it doesn't matter what angle it is, this is always true. And so that's why it's a big idea. And it's kind of cool that it always works out no matter what the angle is. Even if your favorite angle is 1,305 degrees. What's my favorite angle? Right now it's 73 degrees. Oh, it's a long story. Okay, well, maybe I'll tell you it. All right, and the last thing that becomes a big idea for us is if we look at tangent. So on that same triangle, I look at tan and I go tan of theta, I'll erase this now. Tan of theta is opposite over adjacent. My opposite side is y. My adjacent side is x. Right? That doesn't seem too crazy. But if I think that y is the same as sine and x is the same as cos, that means that tan is always equal to sine divided by cos. And that is big idea number 3. So you can put your favorite angle into here, sine of your favorite angle divided by cos of your favorite angle. Will equal tan of your favorite angle. And that's true of any angle as well. Now these big ideas, especially big idea number 2 and 3, those ones we use the most, by the end of this course, you will feel that they're common sense. Okay? Now, there's some things in math that you already know are common sense. Right? When you think about a squared plus b squared equals c squared, do you feel like that's something you've known like for a long time? It's like, it's been a very long time since someone in grade 12 has put up their hand and said, I don't have the formula for a squared plus b squared equals c squared on my formula sheet. Can you write that on the board? Right? Because you just know that, right? There's certain things you feel like you just know after being in math now that you're in grade 12. Right? You meet another student in grade 12, you'd be surprised if they said, I don't know what that means. Never heard of that. Be like, are you crazy? Where have you been? And so at the end of this year, tan is equal to sine over cos, and sine squared plus cos squared equals 1. You will feel like, I've known those for so long because I used them so much. All right. So those are our 3 big ideas. They're going to come up a lot in this unit. Before we go on to the next example, we'll also introduce some more definitions. We have the definitions of secant, cosecant, and cotangent. And their reciprocal trig ratios. So beside here, you can write that secant theta is the same as 1 over cos theta, which means that cos theta is 1 over secant theta. They're reciprocals. And cosecant theta, the definition is it's 1 over sine theta. So sine of theta is 1 over cosecant theta. These are easy to mix up because the one that starts with C goes with the one that starts with S. The one that starts with S goes with the one that starts with C. So you can easily mix them up. And finally, cotangent. Cotangent, theta is equal to 1 over tangent of theta, which means that tangent of theta is equal to 1 over cotangent theta. And if tangent, big idea, if tangent is sine over cos, then a spin-off of our big idea is that cotangent, if tangent's sine over cos and cotangent's the reciprocal, then cotangent is cos over sine. And so to summarize, if you have a unit circle, which means that the radius is 1, right? That's what we started looking at the beginning. Then you can label any point on your unit circle and make a right-angled triangle. The height of that right-angled triangle will always be your y-coordinate. The length of that right-angled triangle, or the base, will always be your x-coordinate. And points on your unit circle will always be your y-coordinate, your x-coordinate, comma, your y-coordinate, and your x-coordinate will be cos of theta, and your y-coordinate will be sine of theta. And with this, your cast rule is explained even further. Because you know your cast rule, right? Here it is, cast. Quadrant 2 has an S. Why does quadrant 2 have an S? Because only sine is positive, right? And if I pick a point here in quadrant 2 on the unit circle, does it make sense that your x-coordinate would be negative and your y-coordinate would be positive? And my y-coordinate is sine and my x-coordinate is cos. And using big idea number 3, tan is sine over cos, positive over negative, tan should also be negative. Take a look at quadrant 3. Pick any point in quadrant 3. Can you see that both the x-coordinate and the y-coordinate are going to be negative? And so that means sine and cos both have to be negative. But tan, which is big idea sine divided by cos and negative divided by negative, makes tan positive. And if you pick any point in quadrant 4, your x-coordinate will be positive, your y-coordinate will be negative. And so cos is positive, sine is negative, and sine divided by cos, negative divided by a positive, will be negative as well. So the unit circle helps explain even further why the cast rule works. And it's kind of nice that some of these things that you've been putting together over time now are like, oh, it's starting to make more sense.
Can I steal your class for about
For
2
sure.
minutes? No.